Namaste to all. So today's topic is proofs of irrationality of root 2, root 3, root 5. So the question is prove that root 2 is irrational. So to prove root 2 as irrational, so we'll try to assume so let us assume that root 2 is rational. So let us assume that root 2 is rational. So if root 2 is rational, so root 2 can be written in the form P by Q, where P and Q are two co-prime numbers. Co-prime numbers, that means they have a common factor of 1. So P and Q are co-prime numbers. So now as we have written root 2 equal to P by Q, if we cross multiply, we can write root 2 Q is equal to P. Root 2 Q is equal to P. So after this, we will square both sides. So squaring both sides. Squaring both sides, we get root 2q whole square equal to p square. And as we know, root 2 square will get 2q square, which is equal to p square. So we'll consider this equation as 1. Which means that 2 divides p square. So if 2 divides p square, we can write 2 divides p. That means 2 is a prime. 2 is a prime and divides p square. Now let us take this p. Let us take this p is equal to 2c. Suppose let this p is equal to 2c. So now putting this p equal to 2c in equation 1, So by putting this p equal to 2c in equation 1, what we will get? We will get 2q square is equal to 2c whole square. Why 2c whole square? Because in place of p, I have written 2c. 2q square equal to 2 square will give us 4c square. Then q square equal to 4c square by 2. So 2, this will go cancel. So we can write q square equal to 2c square. So if q square equal to 2c square, so what we can write? So we can write that 2 divides q square and 2 divide q. That means 2 is a prime. So 2 is a prime number and it divides q square. So from this 2, from the first we have written here 2 is a prime and divides p square, and in this case 2 is a prime and divides q square. Thus what we can write? P and Q have a common factor. Both P and Q have a common factor of 2. But in case of rational numbers, this P and Q should not have any common factor other than 1, isn't it? So this contradicts the fact that P and Q have no common factor other than 1. That means our assumption is wrong. So our assumption is wrong. So if our assumption is wrong, so what we can say? Hence root 2 is irrational. So next let us prove that root 3 is irrational. So the similar way we will go. Let us assume root 3 as rational. Let us assume root 3 is rational. So if root 3 is irrational, we can write root 3 equal to P by Q. Then cross multiply root 3 into Q equal to P. So after that, squaring both sides, we get root 3Q whole square equal to P square. So root 3 square will give us 3Q square equal to P square. So we'll consider this equation as equation 1. So which means that 3 divides P square. So 3 divides P. That means 3 is a prime number and divides P square. Next, let us consider this P as 3C. So let P equal to 3C. So putting P equal to 3C in equation 1. So we can write 3Q square equal to 3C whole square. 3Q square equal to 3 square will give us 3 into 3, 9C square. 3Q square equal to, so 3 we can take to the other side, which will be 9C square equal to 3. So 3 3 is a 9. So Q square equal to 3C square. So Q square equal to 3C square. So we can write that 3 divides Q square. So if 3 divides Q square, it will also divide Q. So if 3 divides Q square, so 3 will divide Q. That means 3 is a prime and divides Q square. So as we got 3 as a common factor, so we'll write here, thus P and Q have a common factor 3. So P and Q have a common factor 3. So this contradicts. Why? Because in a rational number, P and Q should be co-prime. And what is a co-prime? Co-prime means both two numbers. Co means two. Two numbers should have a common factor as 1. But in this case, we got common factor as 3. So this contradicts that the fact. What is a fact? The fact that P and Q have no common factor. No common factor other than 1. So P and Q should not have any other factor other than 1. So this contradicts the fact that P and Q have no common factor other than 1. So which means our assumption is wrong. We have assumed that root 3 is rational. So which our assumption, that was our assumption. So our assumption is wrong. So if our assumption is wrong, so we can write that hence root 3 is irrational. So the next question is, prove that 1 by root 2 is irrational. It's same like the other two questions that we have discussed. So prove that 1 by root 2 is irrational. So similarly, let us assume 1 by root 2 is rational. 1 by root 2 is rational. So if 1 by root 2 is rational, we have assumed, so we can write 1 by root 2 equal to a by b or p by q, anything. A by b, let us write down here, a by b. Then we'll cross multiply, so we'll get b equal to a root 2. So b equal to a root 2. After that, what we do? We square both sides. So squaring both sides. So squaring both sides, we get b square equal to a root 2 whole square, which means b square equal to a square 2. So I can write b square equal to 2a square. So I got b square equal to 2a square. So I can write that 2 divides b square. That means 2 divides b. Since 2 is a prime and divides b square. Then what we do? Again we'll consider this b as 2c. So let b equal to 2c. So we need to consider this equation as 1. So equation 1. So now putting b equal to 2c in equation 1. So 2c square equal to 2a square. So 2 square will give us 4. C square equal to 2a square. So as we have considered 1 by root 2 as a by b, a and b. So a and b should have common factor 1. So let us see what we get here. So the first equation we got b square equal to 2a square. So in this case we need to get a square equal to 2c square. So this 2 will come this side. So 4c square by 2 equal to a square. So 2 and 4 will be cancelled. So 2c square equal to a square. That means 2 divides a square or 2 divides a. That means 2 is a prime. 2 is a prime and divides a square. So which means we got both a and b as a common factor of 2. So thus a and b have a common factor of 2. Both a and b have a common factor 2. So this contradicts the fact that a and b have no common factor other than 1. So our assumption is wrong. What was the assumption? That it should be a rational number. So if it is a rational number, it should have a common factor of 1. But we got as common factor 2. So our assumption is wrong. So if our assumption is wrong, so hence 1 by root 2 is irrational. So next question, prove that 3 root 7 is irrational. So we know that root 2, root 3, root 5, root 7, root 11, root 13, these are irrational numbers. So we need to prove in this question prove that 3 root 7 is irrational. So let us see how to prove this question. Same way we'll be going. We'll assume this 3 root 7 as rational. So let us assume 3 root 7 is rational, which means 3 root 7 equal to a by b. So I can write root 7 equal to a by 3b, isn't it? So since we know that a, b and 3 are integers, right? And a by 3b is rational because they have a common factor of 1. So if a by 3b is rational, so root 7 will be also rational, and so root 7 is rational. But this contradicts the fact that root 7 is irrational. So, but this contradicts the fact that root 7 is irrational. So, our assumption that we have considered that this 3 root 7 is rational. So, our assumption is wrong. Why wrong? Because we got the root 7 should be irrational. So, our assumption is wrong. Hence, 3 root 7 is irrational. The next question, prove that 2 minus 3 root 5 is irrational. So let us assume that 2 minus 3 root 5 is rational. If so, we can write 2 minus 3 root 5 is equal to a. In this case, let us consider it as a, because a is also a rational number, where a is rational. So 2 equal to a plus 3 root 5. So we can write 2 minus a equal to 3 root 5. 2 minus a by 3 equal to root 5. Since 2, a, 3 are integers. Two minus a by 3 is rational, and so root 5 is rational. But we know that root 5 is irrational, isn't it? But we know root 5 is irrational. So our assumption is wrong. So hence 2 minus 3 root 5 is irrational.